Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video we'll be looking at trigonometric ratios and a few of their identities. So let's get started. Okay, so first of all, what is trigonometry and why is it important? So trigonometry is basically the study of the sides and the angles of a triangle. And it is important because trigonometry is used to solve problems everywhere around us in real life. It is used in physics, it is used in chemistry, in architecture, it is used in astronomy, and it is also in fact used in triangulation of signals. So you get that it is very useful to us. So let's understand the basic things about trigonometry and then we will start by taking one step at a time. Okay, so now there are 6 trigonometric ratios that we define, and the definition of these ratios is given using the right angled triangle. So let's make a right angled triangle and name it A, B and C. Now we define 6 trigonometric ratios. So first we start with sine theta. Now sine theta, which is actually the abbreviation of sine theta, this is the abbreviation of this. It is equal to, or it is defined to be equal to opposite upon hypotenuse in a right angled triangle. Let's break it down and see what is happening. Suppose in this right angle triangle, of course this is 90 degree, let this angle be theta. Now if this angle is theta, the side opposite this angle is known as the opposite or the altitude for this angle. Okay, for this angle this is the opposite or the altitude, and the side adjacent to this angle, which is of course the largest side in the triangle, is known as the hypotenuse, and the side adjacent to this angle other than the hypotenuse is known as the adjacent or the base. So base and adjacent are the same thing, opposite and altitude are the same thing. For our videos we will be using opposite and adjacent only. Okay, we will not be using altitude and base, just to avoid any confusion further. Okay, so now sine theta, it is defined to be the ratio of the opposite side to the hypotenuse, opposite side to the hypotenuse. So sine theta is opposite upon hypotenuse, which in this triangle would be equal to AB upon AC. This is the first trigonometric ratio, sine theta, and since it is a ratio, there is no unit for trigonometric ratios. Okay, there is no unit, it is just a ratio. So AB upon AC here is sine theta. Next is cos theta. Cos theta is defined to be equal to the adjacent upon the hypotenuse, which in this case is equal to BC upon AC. Cos theta is the abbreviation of cosine theta. Third trigonometric ratio is tan theta, which is defined to be equal to the opposite upon the adjacent, which in this triangle will be this upon this, so AB upon BC. The next 3 trigonometric ratios are just the reciprocal of these trigonometric ratios. So the first one, cosec theta, also tan theta is the abbreviation of tangent of theta. Now, cosec theta is defined to be the reciprocal of sine theta. So, this is 1 upon sine theta, which actually is hypotenuse upon opposite. So, in this triangle, it is AC upon AB. The next trigonometric ratio is sec theta, which is equal to 1 upon cos theta. So it is equal to hypotenuse upon adjacent. In this triangle, it is equal to AC upon BC. And the last trigonometric ratio is defined to be cot theta, which is defined to be 1 upon tan theta, which is actually adjacent upon opposite, which in this triangle is equal to BC upon AB. So this is the definition of the 6 trigonometric ratios. Alright, so a few identities, the basic identities of trigonometric ratios can be found out using just manipulating the Pythagoras theorem. So in a right angle triangle, say ABC, if this is angle theta, then AB square plus BC square is equal to AC square by Pythagoras theorem. So to get the identities, we can simply do a few steps and get all the 3 identities. So first, to get the first identity, we are dividing by AC square. The complete identity is divided by AC square. That gives us AB upon AC whole square plus BC upon AC whole square is equal to AC square upon AC square, which is 1. Now from the triangle, let's see what AB upon AC is. So AB, for this angle, AB is opposite, AC is the hypotenuse. So opposite upon hypotenuse is sine theta. So this is sine square theta. BC upon AC is adjacent upon hypotenuse. So this is cos square theta. And this gives us the first identity, sine square theta plus cos square theta is equal to 1. Now we can get the next 2 identities by doing the same application. So this time I am dividing the whole identity by AB square. By dividing by AB square, we get 1 plus BC upon AB whole square is equal to AC upon AB whole square, which means 1 plus BC upon AB. BC upon AB for this angle is adjacent upon opposite, which is cot theta and square of that. So cot square theta, which is equal to AC upon AB. AC upon AB is equal to cosec square theta. So we get the second identity, 1 plus cot square theta is equal to cosec square theta. The third identity can be found by dividing by BC square this time. So dividing by BC square, we get AB upon BC whole square plus 1 is equal to AC upon BC whole square. Now AB upon BC is opposite upon adjacent, which is tan theta, so tan square theta plus 1 is equal to AC upon BC, hypotenuse upon adjacent is sec square theta. So tan square theta plus 1 is equal to sec square theta. This is our third identity. All of these identities are basic identities. We could have got them from the Pythagoras theorem. There are different other methods as well to find these identities. So we can get these identities from there as well. Okay guys, so we covered trigonometric ratios and three basic identities in this video. I hope you liked the video. If you did, hit the like button and subscribe to our channel. We'll be bringing more great videos like these. Thank you.